Good morning. No, it's not morning. Good afternoon, everyone. I'm so used to saying good morning. Anyway, up until midday is definitely good morning. Even after midday, surely. If you're doing computer science, it's still good morning. Let's just go with that. Hi, everyone. It is Wednesday. We are halfway through week 3. How incredible. I hope that you have been enjoying the stuff that we've been learning so far. We've been going full steam ahead, so hopefully we will keep going and keep steaming ahead. How exciting! Today's even more exciting because today we get to break out arrays. Oh, so exciting. So yesterday we did a bit of style. Well, we did quite a bit of style, and we learned about why it's important to style our code. We also maybe we agreed. I'm not sure that everyone else agreed with me, but I threw it out there that it is better to style as you go, not right at the very end, or you will be very overwhelmed with the job at hand. So hopefully you're styling as you're going, and you're getting into very good habits straight away. And we also learned about functions. Now, functions help us to break up our code. They help us to segment the problem. They help us to be able to, not have repetition of code, so we can reuse certain modules of code, and we can borrow things as well from other libraries in C as well, which we'll talk about more next week. Today, we're going to talk a little bit about memory because I think it's important to understand what's going on in the computer, the basics of it. You don't need to know it for this course, okay? But I think it's important to understand what's happening so that you understand some of the concepts that we're learning as well. And when you go on to do later courses in computing, you at least come in with a basic understanding of why we're doing certain things, of why we're using certain data structures. And we will introduce the lovely arrays. I love arrays, so let's do that. Okay, so everyone's been asking about the weekly test. Okay, the weekly test starts this week. So if things were not exciting enough as they are, week 3 signals the start of the weekly tests. So what happens with our weekly tests is the name perhaps is a little bit deceiving because what you get is you get a question set that is released on Thursday at 8 p.m. Okay, and you will have until the following Thursday 8 p.m. to submit it. Okay, so that's 7 days worth. But what we want you to do is when you sit down to attempt this question set, time yourself for an hour and use self-enforced exam conditions for that 1 hour. And when you finish that 1 hour, you can see where you're at in the course. So the purpose of these weekly tests is to measure your progress in the course so that you know what you perhaps need to, ask more questions about, what you need to revise, where you need to do more practice, okay? So the point of that 1 hour is to give you a bit of a measure of what's going on with your learning, okay? After that 1 hour, do what you like. You can look at our, labs, you can look at the lecture materials, you can solve those problems any which way. But you cannot talk on the forums about them, obviously, because it's still a weekly test. So that's how the weekly tests will work. So if you have any questions about them, just pop it into the chat. And obviously they're not going to be, as big as the lab. There's not going to be as much to do as in the labs. And it really is to help you be able to solve it. What are the exam conditions? If you're doing this, it's self-enforced exam conditions, which just really means don't look at anything whilst you're doing it, and don't contact anyone else whilst you're doing it. So you are literally trying to attempt it based on what you have learned and how much you remember from what you have learned. So for that 1 hour, based on what you can do or how much of it you can do, it kind of gives you a little bit of an idea of where you need to revise or where you need to go back to and have a look at. Chances are the first few weekly tests, you're not going to be able to finish anything in 1 hour. And that's absolutely fine because you're still also getting used to the kinds of problems that we're giving you, and you're still getting used to the compiler, and you're still getting used to, what you're doing in terminal. So it's really just good practice leading you up to the exam as well. The kinds of questions you're getting is kind of like some of your lab questions. So they're in a very similar structure to that. And you will also have auto tests as well to go with them as well. So you'll be able to do auto testing. And again, you know, you'll have use the give command to submit these as well. So the hour is really, it's a mental limit. Yeah, you have 7 days to actually complete it, but the hour is there to give you a measure of where you're at and how much you know and how much you still need to know and where you need to revise, okay? And we hope that by the time you get towards the end, you will be able to do the questions in that 1 hour, okay? So definitely, you know, you will not be able to probably do them in 1 hour in the first few weeks, especially as you're getting used to the whole procedure. And do not worry about that at all. You are just working towards building up your confidence, and you're working towards building up your problem-solving skills as well. Okay, so that is all about the weekly tests. It's not going to be like the 3-star questions. Those are not the kinds of questions you will have in the tests. So don't worry about that. And definitely no skull questions in the weekly tests. We want you to actually know, you know, be able to measure off where you're at. We don't want you to sort of, you know, feel absolutely devastated by a question. They are doable. They're not, you know, I mean, even the 3-star, you know, you work towards being able to do them. Same as all of your other stuff, you can give as many times as you want, okay? Only your last give will count. So you can give this weekly test exercises, each exercise, as many times as you want, but only the last submission will count, okay? So exactly in the same way as we do the labs and everything else. So there's no attempts per se. You can give as many times as you want. Because what that also does, remember, every time you give a piece of code to us, you are actually creating a lovely backup of that code. So we really suggest that you give as many times as possible, because it helps you, well, it means that if everything crashes, you do not lose your code. You always have a backup there, because we back up everything every night as well. Okay, so any questions, just pop them in the chat. Today in the chat, we have Alvin again, and we have the lovely Shrey in there again, so keep going. They will be answering your questions as well. And yeah, so you submit everything exactly the same way as you submit your weekly tests, and it will be exactly the same way that you submit everything in the course, the assignment, and so on and so forth. So we use a very similar process, and we use a very similar system for doing everything, so that you get used to the way we do things, and you're not, that doesn't form a part of having to think about it. It just becomes automatic for you to do that. Okay, I'm just going to mention, because yesterday I saw that people were talking about the assignment. So I'm just going to say that the assignment is coming early next week, okay? And it is a fun one. Alvin's in the chat, and he is the creative genius behind this assignment, should I say. And we will also be running a live stream about this assignment, that will be also very exciting. So basically, we want to release this assignment before the Tuesday lecture, so I can give you a little bit of an introduction on the assignment, and then on the Thursday evening of that week, so next week, we're going to run a live stream event, and we were going to go through the assignment in a lot more detail. And you know, you'll be able to get a really good solid introduction of it. So the assignment will be using the material of the first 4 weeks of lectures. So you're not going to be able to really, you're going to need what we do in the Tuesday lecture. I'm really going to do something to help you get started with the assignment as well. And what it means as well is that we're starting our help sessions next week. I suggest starting the assignment early, because the help sessions do fill up. You can go in and you can ask for help. You can even ask for help to get started. Okay, so just kind of, oh, someone's picking up my Easter eggs. There we go. So basically, help sessions will start next week. Our first session will run on the Friday, so that you have a chance to watch the live stream on Thursday. And then we're going to, you know, then you can attend a help session on Friday to get help to get started if you want. But you can also follow along in the live stream, which will get you to, some starter code and to really kind of explain what you get and what you need to achieve. So that's going to be the lovely assignment. Okay. Someone's asked, when do the lab marks come out? Lab marks usually come out a week after you submit your lab. So that's when they come out. The assignment will be due. That is a very good question. We're trying to get you as much time as possible. So you will have sort of the flexibility week as well to finish working on the assignment. And we will confirm the due date. So it will either be at the end of that week or at the beginning, very, very beginning of week 7. So I will let you know when the assignment due date is on next week when we talk about the assignment. No, the assignment is not making Pokemon. It's not making Pokemon. Pokemon's done. That has been an assignment in the past. Yeah. All right. So that's a little bit of a treat for you. A little bit of pre-show what is happening next week as well. And don't worry, we've made an assignment. Well, we hope we've made an assignment that is very accessible for you guys, and an assignment that allows you to go through at least the first few stages of it, and to be able to complete them, okay? Because we want you to learn something from this assignment. So it has to be that sort of, a good level of difficulty, but not so that you do not know what to do. And we will be giving you a little bit of starter code as well to help you get started. So yeah, that's going to be the assignment. And there are no classes in week 6 flexibility week. So it's your week off. But I mean, not really, because you'll probably be catching up on all of your classes, but at least you don't have to attend any new classes or learn any new material. So hopefully that will be helpful. Okay, so if any questions, just pop them in the chat. Today's live lecture code is at this location, so in our week 3 location. So we will talk more about, when we get to the code, I'll tell you which file to open up. Okay, let's revisit memory, okay? Just because I think to really understand what we're doing, you need to know a little bit about how memory works. And these are just little tidbits that will become a lot more obvious and a lot more useful in a few weeks' time as well. So I want to introduce them now because they're kind of leading the way with what's happening in a few weeks' time when we get into using memory more. And really one of the reasons we like to start with C language is because C language lets us really see, I'm sorry, I didn't mean to say C and C, but it really lets us experience what the computer memory is doing. So it's a really handy way to understand how a computer functions and how a computer stores things in its memory. And memory is pretty important. Without memory, we can't really do much. So yeah, so things are obviously a lot more complex than what I'm about to explain to you guys. But for your understanding now, you really need to have a very basic idea of what's going on so that you can kind of be able to relate it to, arrays that we are going to go over, but also all the other variables that you've learned about that we've kind of just touched on, because everything that you declare or everything that you initialize, and everything you initialize has to be stored somewhere. It's not just magically hanging in thin air, just like it's got a physical space that it needs to occupy somewhere. All right, so I use this diagram, I believe, in the second lecture. This is as simple as I could make this diagram. This is a very basic view of what our computer memory looks like. And what happens is that when we create our C file, it's stored on the hard drive. Then we use our compiler, so we call DCC, and the compiler converts it into another file that the computer can read. And that's, that's our I wanted to say, no, so whatever you name the file, when you use the -o and you give it a name, that file is now a computer readable machine code file that the machine can read and process. So the compiler is a translator that translates our C file to something that the computer can understand. When we start executing the code, the CPU will actually process the instructions and it will perform the basic arithmetic, but the RAM will keep track of everything that we need in those instructions. That means it'll keep track of any of our variables or anything like that. Any reading or writing of the variables also happens in the RAM. And the RAM is broken up into this heap and stack business, okay? So this is really where all the magic happens. This is where we store things. The stack is a very ordered sort of event, okay? Even by the word of it, you know, a stack. A stack is usually something, an ordered stack of books or an ordered stack of, I don't know, plates. But a stack is usually by definition something that has order. And that's how this stack works as well. So anytime you declare a variable, it, you know, makes its way over into the stack. And then you declare the next variable and it makes its way into the next stack, into the next section of the stack. So on top, and then it just keeps stacking up. And this is in contrast to the heap, which we will learn more about in a few weeks' time. And a heap, again, based on what the word actually means, the heap is unorganized. It's a free-for-all. You go into the heap and you look for some space and you shove things in there. As long as there's enough space. So you can go anywhere in the heap. It is not an organized event. So a stack is an organized event. A heap is not an organized event. And we will talk more about how that affects, especially the heap. It will all come together in a few weeks when we actually learn more about the heap and where things go in the heap. So when you are in this stack, in this lovely place of the stack, what happens is each section of the stack or each level of the stack has its own memory address as well, obviously, because you need to be able to somehow classify memory. And you've kind of used that when you've placed things into memory with scanf. All right, so stack memory is where your functions are called, so where your function calls go. It's also where your variables are created. It keeps track of the variables. So anytime you change a variable, it changes it in the stack. And once your block of code finishes running, so whatever is between your curly brackets, once it finishes running, the function calls and the variables are removed from the stack. So if you remember yesterday, I said when we made a variable, we finish running that program, all those variables just die. And that's what it means. So when you get to the end of your function, when you get to that last curly bracket of where the variable lives, it dies, which means it's removed from the stack. And what it means is that we don't run out of memory because we don't just keep running things over and over and it keeps stacking up and stacking up and stacking up. The stack is cleared all the time when we finish our program. What it means is that at compile time, so when you compile your program, because we tell C we want, I don't know, 3 variables that are ints and we want 2 variables that are chars. What it means is that C actually knows how much memory it will need at compile time. So it will allocate that memory space at compile time because we're telling it the data types that we need. And each data type takes up a different amount of memory. Now, what that means is that we can't change these at runtime. So when the program is already running, we cannot change the space that was allocated to it. We cannot give it more space randomly at runtime. It's already allocated at compile time. So the stack is controlled by the program, not by the developer, which means that we can't, whatever we've said that we want, that's what is going into the stack. The heap, on the other hand, is a bit of a loose unit. It is controlled by us. And we're going to learn in a few weeks how we can control the heap and some memory in the heap and how we can, you know, kill our computers as well if we don't clear the heap too. So it's important to be able to clear it because otherwise the stack will keep building up. If we're doing heap, the heap will keep building up. At some stage, they will meet each other, collide, and you're going to get something called, you know, either a stack overflow or a heap overflow. And you guys probably use Stack Overflow, the website, which is named after this issue that can happen when you overflow your stack. Okay, so memory is obviously important. We need memory to be able to do stuff. So what that means is, we can actually remember things that we've done, or you can remember what we did yesterday, so you can build on that to learn today. Computer memory is also pretty important. We don't really do a lot of it in 1511. We really do the basics in 1511. So you don't have to consider efficiency in 1511 or how efficient your code is. That is for later courses. We don't mind wastage as much in 1511 because you're still learning about how to solve problems. I think first you should be able to solve problems and to understand what structures are available to you to solve those problems before you can actually make them more efficient or think about efficiency as well and how you can decide based on efficiency. And efficiency in computing is all about how long it takes to search something, how long it takes to access something, and different structures provide different levels of complexity and different times that things take. And so based on our problem, we make decisions on what we want to do. And again, in 1511, we don't care as much about what's going on, and often we will direct you what to use to start your problems. So you will know you'll probably need to use an array, or you'll probably need to use another data structure. We will actually tell you that to kind of reduce your problem space a little bit. So yeah, that's pretty exciting. What if the stack overflowed? That's a great question. You're going to get no memory. There's no memory left to continue running. So you're going to have quite a big problem. It's more problematic, when you overflow both of them, they collide. Your computer's going to just cark it basically for a bit, and you might have to restart to clear everything out, depending what you overflowed. It's hard to cause an overflow. I shouldn't say that. I've done it, but it depends. It's easier to cause a heap overflow than it is a stack overflow in our kind of coding. Okay, so is there an actual benefit to building code with less lines? Okay, so there are a few benefits to it. So first of all, code with less lines is easier to read and understand as a human, okay? So there's a style consideration in that as well. Second of all, it depends how many variables you're creating or how many function calls you're making in your code in those many lines. Because each time you call something, each time you create variables, it uses up memory. But again, in 1511, you're not creating anything that's so vast that's going to cause huge issues. So it's not really you're not going to see this problem so much. So let's have a look. Okay, so up until now, we've just been doing some basic structures, not structures actually. We haven't learned any, we've learned one structure, the struct, but we will also learn about arrays in this course and linked lists. And so today we start arrays, which is amazing. And then we're going to do linked lists after flexibility week. So you've got so much to look forward to. So very exciting. And there are, of course, other data structures. It's not just arrays and linked lists. There are plenty of others that we do not learn about in this course, but you will learn in later computing courses. But we introduce you to two particular data structures here. And as you go on in computing, so in 1511, we will often tell you which data structure to use to solve your problem. But as you come to more complex problems, and as you start working out more problems, you will have to be able to choose which data structure you're going to use to house your data. And it really depends on what kind of problem you're trying to solve, and also on what you're trying to achieve. So some structures lend itself better to certain types of problems, really. And it all depends on, how long things take to search, how long things take to access. And it all depends what kind of problem you're having and what kind of problem you're solving. And again, it's all about practice. It's all about understanding and practicing and solving different problems. And sometimes, the thing is you can solve each problem using 3 or 4 different data structures, but each problem will have, different pros and cons to it. And so as you kind of get practice with solving it differently, you will see what benefits there are and which forms a better solution for you. But again, in 1511, you don't have to worry so much about it. But I just want to give you a little bit of background why we have these data structures as well. Okay, I think also today, you're going to see me draw, which is, you should be very, very pleased. Not really. Okay, so what is an array? Who has heard of this wonderful structure called an array? So far we've learned about structs, and structs help us to create a structure with different data types in it, which is very exciting when we can have a collection of related things of different types. But an array is the other way around. The array is different to that because it uses the same data type. So it's a collection of variables, all of the same type, okay? And what it allows us to do is if we have a collection of variables, all of the same type, and we want to deal with that collection as a whole, we use an array because it helps us to access any variable and it helps us to change any variable easily. And so it allows us to do a whole bunch of things. And the reason it does that is because in memory, an array is stored, elements of the array are stored one after another. So you know how easily to access everything. You can easily just go from one to another. So let's just have a look at a few. I'll draw an example of it in a second so you can see what it is. Actually, let's draw an example of it now. I'll show you what it is. Now, if anyone has done, I'm going to take you back to your lovely times when you were in school and you were first starting to learn about fractions. We're going to kind of go to that. Okay, so an array is really a box that houses all of our different variables. So what we have is a box, and that box, because each element in the array is of exactly the same data type, okay? So each element of the array is exactly the same data type, which means that our box, just like our beautiful fraction bars, are broken up into equal spaces that houses that those data types. So what I've created here is an array with 4 elements in it, okay? So this is an array. Oh gosh, it did not draw that. And it's got 4 elements inside this array. That's terrible writing, I'm sorry. Okay, so our arrays, I'll just go back to so let's consider for now, the most important thing about an array is the fact that it only holds things, each array collects things of the same data type, okay? So for example, let's say I want to record the daily case numbers in New South Wales during the COVID-19 pandemic, okay? That lends itself to an array. Each section of it is going to be an integer to record the daily numbers. But they're all related because they all relate to the same concept. I'm recording the daily COVID-19 case numbers, okay? And so it's going to be an array of many ints. So another one, I could record the daily temperatures. Again, it's ints. The amount of time daily that I spend walking my dogs, how many deliveries I get per day during lockdown. And I'm going to use an array of ints as my first example, just so that you can get familiar with what an array is. And then we're going to build on that, and we're going to do a different type of array after the break. So let's, can you guys think of any other problems? Can you guys think of any other examples where an array could be useful? I think there's a little bit of a lag in me speaking and you guys hearing what I'm saying. Yeah, so someone said COMP1511 exam results. That's a great example. Can we think about arrays as kind of like a vector? Potentially. Yeah, vectors, yeah, that's a good one. Ours daily questioning existence. Yep, especially during lockdown. The word addition problem. I can't remember the word addition problem. Calculating circle elements. Yeah, students' grades is a really common one. Just things that we're putting together and holding together. Daily returns in a portfolio, yes. Time, depending on what context, but yes, you can absolutely keep track of times during the day. How many snacks you eat, yes, that's a great one. How many pieces of furniture in each person's room, yes. Study time for comp per week, yes. Phone contacts, yes. Those are really great examples. Well done. Daily screen time, let's never keep track of that. But yes, you can absolutely keep daily screen time. Wait, yes. Waiting list, yes. Those are really good examples, okay? So the one thing about an array, and it is of a fixed size. We have to let the computer know how big an array we want, okay? And that size cannot change during our runtime of the program. It has to, so it's a fixed length, and we decide what the length is. So often one of the problems we see with arrays is we sometimes don't really know how much space we need, and we're going to give it a really big number just to, guard us against running out of space. But what it means is we waste a lot of space as well. If I create an array with 1,000 spaces for ints, and then I only use 2 of them, that's a lot of wastage. But I mean, with the current computer power, it's not, well, shouldn't normally cause a problem, but I guess it can depending what else you're running and stuff. Okay, let's look at this. I'm going to go and back to the drawing board and okay, so let's have a look at our array. That's the problem because I went pen, but I think maybe pencil is better, it draws better. Okay, so in our array, let's say I want to keep track of the parcels that I receive during this beautiful lockdown, and it did intensify during a period of isolation. So I suppose some parcel deliveries, or we can go with, no, let's just go with parcel deliveries because that's the example that I make in the lecture notes. Okay. So let's say I want to keep track of the number of parcel deliveries I get in any given week. Well, just in a particular week, actually, not in any given week. Number of parcel deliveries I get in a week of lockdown. So there are 2 ways to solve this problem, yeah? I could either go on and I could create a variable for each different array. So I could actually do something that looks like this. So I could say, okay, int Monday, I received 3 parcels, or I received 1 parcel on Monday. I can do int Tuesday, I received 2 parcels on Tuesday. Int Wednesday, I received 3 parcels. You can see already this is getting a little bit tedious, isn't it? Int Thursday, imagine if I was keeping track of a longer time period even. That would be a bit of a problem. It's not helping that I'm also just typing the full name of the daily week. So if I'm solving this problem just with the information I have now without knowing of the availability of arrays to me, I'm storing each number into its own variable, which seems like sort of kind of inefficient because really all these numbers are related to each other. I'm keeping track of how many parcels I received each day of the week. So it's a related collection, all of the same data type. Because now, let's say I want to know if the parcel number is greater than 2, then I might then say, okay, it's a little bit extreme. You need to slow down on the purchases. You know, calm down. Things are not that bad. Lockdown will end soon. So how would I do that? I would probably have to test each one of these. So if Monday is greater than 2, then I would say, all right, let's slow it down. Okay. But then I would have to really do it for each one of them, don't I? I would have to do it. Oh, I am missing a lot of equals. Yes. I'm doing hash defines here, except without the define and without the capital letters. I'm just overly excited about my parcels. It's Wednesday. I should receive 3 today. And then what do I have to do? Oh my goodness, then I have to keep going. So if Tuesday is greater than 2, this seems like a very inefficient way to do things. What do you guys reckon? Do you reckon this is a good way to solve this kind of problem? What could we do to fix it? What can we do to fix it? What would you do to fix it if you still didn't know about arrays? What do you guys reckon? Oh, someone's already received 3. I only received 1 today already. Okay, someone probably used copy and paste, absolutely. It definitely works. It's quite long. I am repeating a piece of code. So I could, you know, if I couldn't make an array, what I could do is I could take something out to a function as well. That will still not make it particularly efficient. It would improve it a little bit. Yeah, so functions could be a fun way to do it. But still, the inefficiency is there, as you can see. And this is only for 1 day. I mean, I could do if Monday or Tuesday or Wednesday or Thursday or Friday or Saturday or Sunday is greater than 2, then I could print that out. But that is also not a nice way to do it, because then you get something that looks, you know, pretty style-wise is not a really good way to do things. So if I have this nest here that is just madness, and then how will I know what I should put in here as well? How do I know which day to put in? Because this is quite specific to the day. So it becomes this problem where I can't really solve this. I mean, I can solve it. It's not a problem, but the code is going to be, I don't know, 60 lines long, and it doesn't need to be that long. It's not really a very efficient way to do it. So we could move the comparison out to a function. Should we do that? Should we move it out to a function? I don't know. No, you know what? We're going to leave it, because otherwise we're going to run out of time, and I want to talk about arrays. And then we can move things out in the arrays about functions. So then you would keep going like that, and it would get very, very tedious. So you would have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, and it would be a piece of code that is just, you know, it would just be madness. And even if you did have a function, you'd have to call the function each time with the different day so that it knows. So you'd have to give it an integer. You'd have to call it for Monday. You'd have to call it for Tuesday. You'd have to call it for Wednesday. You'd have to call it for Thursday, Friday, Saturday, and Sunday. So again, whilst more efficient and a cleaner way to do it, because you wouldn't have 7 of these if statements, you would only have 1 if statement in the function, but you would still have 7 function calls, which is also not an ideal solution. Okay, so it still becomes style-wise, it becomes quite a messy way to do it. And so this is where an array comes in. So let's say I want to solve this problem using arrays. Yeah, so I'm going to transfer this whole thing into an array. And we're going to talk about a few specific things about an array that make it a little bit weird, but also a little bit wonderful. So I'm going to draw my beautiful array box, and I'm going to divide it into 7 equal parts. Now let's not, I'm not sure they're going to be equal. I'm not sure that I'm that good at approximate measurement, but I'm going to try. So 1, 2, 3, 4, 5, 6, 7. Oh, that's pretty good. I'm very impressed with that. Okay, so I've got 7 components for this array. Now, if you remember about 10-15 minutes ago, I said actually we need to let them know, the computer bits, we need to let computers know what we want our array to be, what we want the size of our array to be. So in this case, we're telling the computer we want an array with 7 elements in it. Now, I also want each of those elements to be an int, okay? So I'm going to have an int array. That means that each one of these elements is an int. And we also index our arrays, okay? Now what it means that we index our arrays is that each element of the array has its own place in that array, and we index that place so that we are able to access that element very easily as well. Now, the one bizarre thing about arrays, well, not bizarre, but just one annoying thing about arrays, well, not even annoying, arrays are still beautiful, but indexing always starts at 0, okay? So if you have 7 elements in your array like we do, our indexing is only going to go to 6 because the index starts at 0. So that means that our index is going to be, the first element is at index 0, the second element index 1, the third element at index 2, fourth index 3, fifth element index 4, the sixth element at index 5, and the 7th element at index 6. So what you get then is you get the fact that each one of these boxes is an int, and you get the indexes that are associated with the array. So you can access any of those boxes as you see fit, okay? And you will be able to do that by knowing I think Catherine's asked a good question. Can we have 2-dimensional arrays or 3-dimensional arrays in C? You can. And we're going to be doing 2-dimensional arrays next week. So, hold on to your hats. It's going to get even more exciting. So we've got just a 1-dimensional array. Now you're all going to think 1-dimensional. This is a bit boring, but let's start with just 1D. So we've got our indexing in the array, and we can pile things into those indexes. So let's see what it looks like in code as well, just so that you can see how we can see that we want something that is an array, and how we can actually play around with it, okay? So let's use this lockdown parcel situation again, and we're going to work on that. So let's say now, instead of this rubbish, well, not rubbish, but instead of 7 different variables for each day of the week, I'm going to tell C here that I actually want an array to store them in. The same way we declare an array to be able to use it. Now, to declare an array, again, we say what data type this array is storing. So exactly the same as a variable. To declare it, we give it a data type. I want it to store ints, so my array is going to be an array of integers. And so what we get, then same way as in a variable, I'm going to give my array a name. And to be really creative, I'm going to call it parcel week. And then I need to let's see, right now it just looks like a variable of type int. So I need to let C know, actually, I don't just want a variable, I want an array. So to say to C that you want an array, you put these square brackets after the variable name. No spaces between the variable name and the square brackets. And what that tells C is that you want to create an array. Now, I've said to you before that we actually want to tell C how many elements we want in that array. And there's two ways to do it. Either I can specify in here that I want an array with 7 elements in it. And what that means is it will create an array with 7 things in it. Now, remember how I said that this number cannot change during runtime? So if this number cannot change during runtime, then it's really a constant, isn't it? So often what we do is we define the size of our array inside using a hash define, because it doesn't change, it's constant. I shouldn't have typed constant. Hash define. I even said hash define and then I was talking about a constant. Okay, and let's call it number of days, and I'm going to give it the value 7. And then instead of using this 7 in here, you can just say it's going to have n days as the value. And that means anywhere where this is, we substitute 7 in. So this is creating an array with 7 bits. So this means I've declared an array. But what about initializing it? I really need to initialize an array for it to be able to do something. And we can do it a few different ways. Okay, so obviously we can initialize it same as we do a variable by telling C what is going to be inside it to start with. But you can also take input from a user what they want to put into that array. So let's do it to start with, just us telling the user what is in it, okay? Let's do that. So let's do in here, and we can say equals to initialize an array. So we've declared it. Now we're going to initialize it. Whatever is going inside my array is going to go in curly brackets, okay? So I've got Monday 1, Tuesday 2, 3, blah, 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 so on and so forth. The way I put it inside here is just separated by a comma. So I've got 7 things in here. Now, mind you, if you've got the wrong number of items in here and you've said you're going to get 7 elements, you don't put 7 elements, it's gonna yell at you. And we're going to see that in a second. I will demonstrate a few of the errors that you're going to get. So basically, now what you've done is you've declared an array with days of the week, okay? So if we look at it visually, what you've done is you have created an array here, and this array here is called no, that's really messy. I'm going to go back to this. So this array here is called, I'm going to have to write sideways because I haven't left enough space. So this array is called parcel week. Oh my gosh, this is terrible writing. And there's 7 elements in here. And the array, when I've said in my curly brackets, I said 1, 2, 3, the way it comes in that order is the way it's placed into my elements. So these are the numbers in the curly brackets that I initialize the array with, and that's the order in which it goes into my array. So what I've done is I've initialized it and I've loaded up numbers into it. Now, to be able to access any of those numbers, okay, what I want to do is I want to reference this index. So what that will look like is if I need to access any of those at all, I can just say which one I want. I can say the name, so the name of my array, and in my square brackets, I'll say which index I want. So if I've said I want parcel week at index 0, which is what I've said by using this square bracket, it will be equal to 1. If I say I want parcel week at index 4, it will be equal to 0, 1, 2, 3, 4. So it will be equal to 5. Because remember, the indexing starts at 0. It doesn't start at 1. So the index is always, kind of one one behind. So just remember that that's what the indexing means. If you try and access, so I've got 7 elements. If I try and do parcel week 7, okay, so if I want to access something at index 7, note that I don't have index 7. I only have up to 6 indexes here. So if I try to access something at index 7 where there's absolutely nothing here, it's going to yell at me. And so it should, because I've just tried to access something that doesn't exist, okay? So, and this is really a very common error, because sometimes, you kind of go, okay, I've got 7 elements. I want the 7th one. I'm just going to call for a 7th element. But there is no 7th element. The 7th element sits at 6th index, because indexing starts at 0. So it is a common error. You will make it a few times before you stop making it, and then you'll make it again a few times before you stop making it. So that is one of the first things to check when you're playing around with arrays. Okay, so how would we implement this? And we're getting close to a break time, but how would we'll go for another few minutes. Someone's just done it. Yes, you could absolutely use a loop to add elements to an array. And in fact, loops and arrays are best friends, okay? They go hand in hand. So we can't print out the whole array, okay? But we can print out different elements of the array. And because the indexing is consecutive, one comes after another, and the numbers go up from 0 to however big the array is, and we always have to let C know how big our array is. We have the perfect conditions for a while loop, okay? So that means that, while loops are going to be everything. It's going to be like you're literally going to be doing a lot of while loops now to play around with arrays. So we can't printf a whole array, we can't scanf a whole array, but we can do separate elements. And so we use those loops to cycle through the separate elements. And that's what we're going to do right now. So let's do one where we're just going to print out the different numbers of the parcels, okay? How does everyone feel about that? Let's do a quick piece of code where we're going to cycle through and print out the different parcels that we have, okay? And then we're going to take a break after that. Okay, so we don't really do for loops in 1511, but there are reasons for it. But it depends. Some people do prefer for loops, but don't worry about using for loops for now. Everything that you can do in a for loop, you can do in a while loop as well. Okay, so we've got our array here. The array is got 7 elements, and we have initialized the array. So let's have a look how we can print out the different elements of the array. So if we're going to create a while loop, remember that there are 3 things into a while loop. We need a loop control variable. And often when we play around with our array, you've heard me say we refer to the index that a certain number sits on. So we often have the index is usually this I. Now we've said before that during style we're telling you, okay, don't use these single, letters. They don't mean anything. This is probably one of, sort of the rule where you can break that rule, because I is fine to use. It's kind of a consistent standard way to pulse through an array as well, because I stands for index and it's used consistently throughout. Now, my array starts at index 0, so I'm going to initialize my variable I to 0. And now I'm going to do, don't worry, you can use for loops. You can use them, it's not a problem, but we just don't teach you them. You don't have to change it. So I've just answered a question on the chat, sorry. Okay, so first part of my while loop is creating my loop control variable. The next part is going to be some condition of my loop. And then, of course, I always have to increment. And remember yesterday we talked about doing I++ to increment by 1. It means the same thing as doing I is equal to I plus 1. Okay, now what should my condition be? I want to loop through my whole array, okay? So I want to go from index 0 to the end of the array. So what do you think is going to be my condition in the while loop? What will I be doing in here? I think there is a huge delay. Yeah, okay, there is a huge, Alvin just told me there's a huge delay in me asking a question and you being able to answer it. Oh, fantastic. Yes, well done. So I has to be less than 7. Now, why do you guys reckon we're not saying I has to be less than or equal to 7? Why aren't we doing that? And yes, people are using the hash define. Fantastic. N days. Yes, that was going to be my next. So we can use n days instead of the 7 because that is 7. Why do you think we're not equaling 7? Why do you think I'm not saying equal to 7 here? So I'll wait for you guys to tell me why I'm not equaling, but I'm going to say, okay, I'm going to print out. And what will I print out? Yeah, well done, because it starts at 0. There's no 7th element. There's no index 7. So that's why we do not go up to an equivalent to 7, because we'd loop 1 too many times and we would try to access something that doesn't exist. And we might do that in a second just so you see what error it gives you when you try and access an element of an array that doesn't actually exist. You've just traveled outside the array. So let's print out the number that is there. So I'll go %d, and I might put a new line in. Okay, and then to access the variable that I want to print out, I'm going to use the name of the array and the index. Okay, and remember my index is going from 0 to 6. So this is going to keep changing each time, which means it's going to be accessing each different section of the array, each different element of the array. So this should be able to print things out for us. So let's have a look. If we compile this piece of code, let's do DCC. Okay, so I've made a few mistakes. Can anyone pick up? Did anyone pick up? No, I forgot to close a bracket here. So let's fix that. Bracket is closed. Let's see if that likes me now. Okay, now it likes me. Excellent. And now let's run our program. Did anyone pick up the other mistake I made? What other mistake did I make in the code? Yeah, that's right. The opposite way. I went crazy on the new line and I put it the opposite way. Well done, guys. Well done. I'm glad people are still awake. People are still concentrating. So let's quickly compile it again and run it again just so that you can see what's going on. And now it's printing them out 1, 2, 3, 4, 5, 6, 7. And just before we take a break, let's see what happens when we try and access something that doesn't exist so that you know, and this is a common problem, so that you know what's happening when you do encounter this problem. So if we try to run it when I'm accessing the 7th index of the array, it will tell me, warning, iteration 7 invokes undefined behavior because I have now gone outside of my array. So I've ruined it all. I've killed the array. Okay, well now is probably a good time to take a 5-minute break so that you get a little bit of a break and then we will continue learning a little bit more about arrays. We might do a scan into the array and then we're going to do something even more exciting. All right, have a good All right, welcome back. I forgot to also take off my camera, but I am loving these solutions. Some of them are absolutely hilarious and fair, absolutely fair. Especially someone is throwing these light bulbs in a pillow factory. Great idea. I like it. And and just suggesting that it is an inaccurate experiment. Yes, I agree, would be, wouldn't it? But yeah, a few people have kind of got the right idea. So you would start at floor 20. If it broke then you would perhaps bring it down, to floor 10, try from there, and so on and so forth, and then increase it by a certain amount each time. And the optimal number, if you do an optimal number, it would be 16, the least number of drops. And that's if you go up 16 floors at a time. So yeah, that apparently is the way to do it. There are some very creative solutions. I love it. Well done, guys. Well done. That's really lovely to see. Okay, let's not solve this problem yet. We're going to keep solving our problem that we have. We're just going to play with one array now to start with, and then we're going to go on and do the slightly different array to show you a bit more practice with how to use them. Okay, so far I've initialized this array and I've told it these are the numbers that I would like for you to take up. So these are the numbers that I will initialize you to. Let's say now I wanted to scan in instead. So I want to scanf each result from the user. So I want them to tell me how many parcels they received on Monday, how many parcels they received on Tuesday, and so on and so forth. So, and then we're going to print them out. So the print loop stays. So this section here is where we print out the different elements of the array. But now let's say we don't want to initialize it. We want to initialize it by scanning user input in, okay? So initialize the array by scanning in user input. Okay, so similarly, we're going to loop through this array. Oh, Theo, you asked a beautiful question. You can put an array into an array, and we're going to do that on Tuesday next week. You can put anything into an array. Our next problem, we're going to put a struct into an array, because why not? We can live a little. As long as it is the same data type in each of the elements, you can put anything into an array, including an array. So you can create some pretty nifty things by doing that. Okay, so let's initialize the array by scanning in the input. So I'm going to get rid of this equals and this lovely curly brackets here. That was actually initializing it for me. And what I'm going to do now is I'm going to create a loop that's going to scan in user input. So again, because I'm creating a loop, I'm going to have a loop control variable, and I'm going to make it equal to 0, not to O, because that would be bizarre. And then I'm going to have another while loop. And you've already given me the condition for my while loop. And in fact, it's the same condition, because again, I'm going to go through the array and place things into an array one element at a time, okay? So again, the condition will remain the same, but not with the equals, because remember, we don't have the 7th element of this array. We only have, the 7th index of this array. We only have 7 elements, but 6 indexes. Okay, so the condition is the same, and of course we don't want to forget to increment our beautiful loop so that we don't get stuck in a lovely infinite loop. And now, instead of printing things out, we're going to scan things in. But first of all, we're going to ask the user what, we're going to give them some prompt as well. Okay, so how many parcels did you receive on day? So should we ask them on day blah and then refer to our beautiful index? Let's do that. just for fun. And so I wanted, instead of that D, I want to print out the index. So we'll say on the 0th go, on the first loop, it'll say how many parcels did you receive on day 0? How many parcels did you receive on day 1? That's not really efficient, is it? Because there's no such thing as day 0. Apparently. Maybe there is. No, I don't think there's day 0. And then whatever the input is, I'm going to scan it in. Okay, so I'm going to scan in the %D. And remember, always the ampersand. And I'm going to put it inside the array. So I'm calling the name of the array. And then I can't just place it into an array, huge array. But what I'm going to do is I'm going to place it into the index of the array that I'm at currently. Okay, so if I'm at the 0th, so when I start at 0, I start here. I want to put it into the 0th index. Then I'm going to increase it by 1, and the next number is going to go into the first index. But yeah, Zach, well done. You could just do I+1 here so that it says it nicely. It will actually give me a much nicer number. So let's do it with 0 first, and then we're going to print it out here. Okay, so let's see how that works for us. So I'm going to run it again, compile it again. I've done something. Where have I done something? I've forgotten a bracket somewhere. Let's have a look. Probably forgot it in the again, I forgot a bracket and a semicolon. My goodness. Lucky there's a lag, otherwise someone would have really told me about it by now. But hopefully we can clear up this lag so it's not as big for next week. Okay, let's compile it again. And what's happened? It's telling me this error here. It's telling me red definition of I, int I is equal to 0. Why do we think it's doing that? What do you guys reckon? I know that there is a slight delay, but why do you think this is happening? Ah, thank you, Lisa. You saw me, didn't close bracket and forgot a semicolon. Yeah, because I wrote it twice, but I could have it twice, couldn't I? Because at this point, when I gets to over here, when it exits this while loop, I is going to be equal to 7. So yeah, yes, someone said it because I declared it twice. I've tried to declare something else. I don't really need this int, but I'm going to knock I back to 0, okay? That's right. So that just means twice. I've declared it twice, and I can't really declare the same thing twice. That doesn't really make sense. So that's what it's complaining about here. So let's run this now, and let's run our... And now it's going to ask me how many parcels did you receive on day 0? I received 1 parcel and I'm just going to build it up here. And then it's going to print stuff out for me. Now you'll notice over here it said 55, if you notice that, which is super awkward, but it's because over here I tried to type too fast and I actually entered 45 here. So what it did is it read this 4 from the buffer, then it read this 5 in here together with this 5 here. So it actually put 55 in. So that is also a mistake to watch out for. Slow yourself down if you type fast. So that seems to be working nicely. So now we've been able to scan into an array, access different elements of an array, and also print the array just by looping through it. So loops and arrays, best friends, because it allows us to loop through the different indexes of the array and do lots and lots of different things with it. So now let's have a look at a more difficult problem. Because who doesn't love to go, just that one element up in difficulty? All right, and the problem is 4 players are playing a dice game. For every round of the game, each player rolls 2 dice, and the sum of those dice is their final score for that round. After everyone has rolled their dice in the game, we want to be able to find out who won that game, which is the highest score. And we also want to know what the total of the scores is in any given round. And we're going to try to break down this problem right down to, trying to get it all the way down. So let's have a look. So we'll switch over to our array scores, and I've put the problem in here as well so that you don't have any split attention going on where you have to look between one and the other. So let me kill off the slides so you can see into our gedit file. Okay, so there's a few things here, and we need to really break down our problem. Okay, so first of all, there's 4 players always. That does not change. So we can use something special here. What do you guys reckon we can use here for the 4 players if it is a number that does not change? This 10-second lag is going to kill me, I think. So what do we reckon? Yep, hash define, well done, well done, well done. So we'll definitely use a hash define here to define the number of players. So I'm going to pop it in here, and I'm going to use my hash define already, hash define number of players, and it's going to be 4. Okay. Fantastic. Now I'm going to roll the dice, and I need to find out what their dice was. But the 2 dice that they roll, they're going to roll 2 dice together, and the 2 dice that they roll really kind of belong together because they form really a collection of what their score will be. So instead of doing 2 variables, dice 1, dice 2, and kind of doing it for each and every player, I'm going to use a struct. Now, I don't necessarily have to use a struct in this problem, but I would like to so that you guys get more practice also from using structures as well. So if you remember from last week, a struct is a collection of things that I define, so it's user defined, and I can put any data types in there that I think are relevant to me. So to define a struct, I use the keyword struct, and I give that struct a name, okay? So that's going to be, I don't know, I guess dice is a good one, I suppose. And then I do my curly brackets to define it. And inside it, I'm going to say I've got 2 things. I've got die1, and I've got die2. Okay, so now I have 2 dice that are together, and I've put them, actually, you know what, I don't want to call it a dice. I'm going to call it, no, I'll call it a dice. Okay. Okay, so I've got a struct now that groups the 2 dice together that the players are playing with. Now, when I roll the dice, what was their dice? I guess to find out what numbers they rolled, I'm going to use a scanf in there. And then I've got to sum the 2 dice that they're telling me they rolled. So let's see what we have to do in here. Okay, we've kind of sorted this one out. We've said that everything's okay. But now we really want to have some sort of storage space for our roles, okay? And so this kind of lends itself pretty nicely to an array so that I don't have 4 different variables, which in fact would be 8 different variables because each player, and there's 4 players, rolls 2 dice each. So by the time I add them up, I will have just a ridiculous amount of variables. So it's better really off to be putting it inside array. And then we can play around with what's going on. It becomes much easier then to figure out who's got that top score, the highest score, because I can just pulse through my array and see who's got the highest score in there. So I'm going to store their scores inside the array. Okay, so let's have a think. How would we do it? Okay, so what do we reckon we would do first? And I've said before, an array can be, you can have an array of anything, okay? And what I want to do now is just to show you that you can have an array of anything. I'm going to be a bit of a pest, and I'm going to create an array of structs. So let's do an array of structs, and I'll show you what that looks like visually. Okay, so let's say I've got 4 players. That means I want an array with 4 elements. And I want to have an array of structs, which means that inside here, I'm going to have my struct. Struct. I forgot what I've called the struct. I've called it dice. Now that struct dice has 2 ints in it, okay? Which means that each one of these elements is actually going to be the size that is required to store, the size that it requires to store 2 integers. So we always define our structs outside of the main because we want that struct to be available for all the functions in our code, which is why we do that. Okay, so that means that each one of these is actually going to have a struct inside it. And the reason I want you to see this is because an array can have whatever you want in it, as long as it's the same type each element has. And that's what I'm doing. I'm creating an array of structs. And it allows me to group a lot of different things together. When I can put together arrays and structures, it's amazing that it gives you a lot more flexibility in how you can solve problems. So I need to be able to really let's declare this array first. So declare, even spell it correctly, declare an array of structs. Okay, so before, in the question before this that we did before the break, we did int parcel week, and then we did a square brackets. So to declare the array, we said what data type it stores in it. Then we said what the name of it is, and then we gave it square brackets to show that it's an array. Now, it's exactly the same, even if it stores structs in it. Sorry, choking. So I will say what data type it's storing that array, and it's storing struct dice, because that's what I've called my struct, so struct dice. So I'm saying that this array is made up of struct dice, okay? That's what the data type is. Now I want to have a name for that array, and I'm going to call it a role. You can call it whatever you want. That's just what I've come up with. And then I'm going to give it some square brackets, okay? Because the square brackets is what tells it that it is an array, in fact. And so what that means is when we declared this int parcel week, it used up, and we had 7 different elements. Each integer is 4 bytes. It used up 21 bytes straight away. Now, this time we're going to have a certain amount of roles here, and the roles are not, there's only 4 players, so that's what I want to keep track of. So I'm going to use that hash define again in here. So each element of the array now has a struct in it. The struct has 2 integers in it, which means that each element is now 8 bytes, okay? So there's going to be 8 bytes in each of the 4 elements of the array. So altogether, it's now taken 32 bytes. And they're not large amounts of memory. You know, you can really go crazy with it. But that's what it does. This is why we tell it what the size of the array is, because it gives us a chance to kind of, reserve memory for it. Okay, so this is an declared array, but it's not initialized. Now, one way I can also initialize an array, so we did the scanf before. If I want to give an array an initial value of 0, I didn't show you, but the other thing that I can do is I can just put 1 0 in here. What that does, okay, even though I've got 1 0 in here, if I have this 0, it gives zeros to everything in that array. So what it would do is, in fact, it would go in here and it would just go, okay, you are 0, you are 0, you are 0, and you are 0. So that's initializing everything to 0. And it does that by it just gives everything 0. It doesn't mean you don't have to type 0, 0, 0, 0. If you put that 0, it just gives everything zeros. Okay, so if we roll the dice, which is the next step of our solution, that happens outside of our program. Okay, so you're actually rolling physical dice. But we want to know what it is that you got from that dice. Yeah? Okay, so someone said, where did the roll come from? It's not part of the struct. So struct dice is the type that I want to store inside my array. Roll is the name of the array, so it's my variable name. And in here, in the square brackets, is the number that I want, the size that I want that array to be. So that's how it happens. Okay, so let's roll the dice. That happens outside. And now let's scan in the numbers. Okay, so we know that when we scan in the numbers, we've just done it with a very simple int array. We know that we just use scanf on a loop. So we really need to have a lovely loop control here. So int I is equal to 0 to start at index 0. And then we want to be able to have a while loop so we can go through all the different elements of the array. We're going to have some sort of condition in there. And of course, we're always going to increment or update our loop control variable. So what happens in here now? Okay, so first of all, our condition, again, as before, we want to cycle through all the different elements of the array, all the different indexes. So we're going to go from I is equal to 0, which is where we've started here, until I is equal to the size of the array. So I has to be less than, and then our size of the array, which is n players. It's our hash define, okay? So let's then do a little prompt for the user. So let's do a printf, and we're going to say, please enter player D, and I'm just using different so that you get to see how it works. So also spelling, first die, okay, and the variable name there is going to be my I, and then I want to scan it in, whatever they're telling me that they've rolled, I want to scan it into my array. So remember that inside the array, there is a struct, okay? So inside each array, there is a struct, which means that what I'm scanning into, there's two potentials. If every element of the array has two integers in it, remember that I can't just go, okay, I'm going to scan it in here and that's it, because I need to tell it which one is it. Is it die 1 or die 2? So in my array, each element has die 1, die 2, die 1, die 2, die 1, die 2, because a struct is stored inside each of the elements. So if I've got the first die here, I'm going to store it into my array. The name of my array is roll, okay? So the name of the array is roll. And I'm going to store it into the index I, because I has just started from 0, okay? And then I need to put, if you remember, to access the struct that I want, I put a dot, which allows me to access the member of the struct that we need. And then I put which one of the variables in here I want to pop it into. And in my case, I want to put it into die 1. Yes, whoever's noted. Yes, I did forget a semicolon. And I forgot a bracket now here as well. You see, I get overexcited. Semicolons are the bane of my existence. I have nightmares, just semicolons chasing me around. Thank you. Thank you. So if you haven't noticed me missing semicolons, please let me know, because that's always been an issue for me. Okay, so now we've scanned into the first players. We've scanned in this lovely die 1. And now we really need to do die 2. And we can see that it's really going to be exactly the same piece of code, except that when you're scanning the second one, you're going to put it into die2 in your struct. Okay, so now I've got an ability to scan all of these dies, okay, which is pretty fun. So I now can take in what the user has done. So I still can't really, I mean, I can test it. So let's have a look what it does. I do like to run the code from time to time so we can see what it's doing. So let's have a look. Okay, Zach, absolutely not a silly question. In fact, a really great question. Zach is asking, if a struct is a way to store data, what is the point of using both a struct and an array? A struct is just a way to store data that might have different data types in it, but it's just, I'm still storing just like one thing. So if I want to have more than one of it, I have to have still 10 variables, right? So each day of the week would have a parcel number, and it would have like a character for the day of the week. I'd still have to have 7 variables, okay? So I'd still have to have 7 instances of that struct. But when I have an array, what it allows me to do is to have one data structure holding those 7 elements, but each one of them is a struct. So what it means is I don't need 7 different variables. I can just have one array that I can easily access things with, and it allows me to, hold a struct in each of the elements. So it still has a really excellent, application, basically. Okay, so let's have a look. No, I haven't run it yet because I went to see what it's called. I forgot what it's called. Array scores. Okay. All right, so now please enter player zero's first die. Let's say 2, let's say 3, let's say 3, 3. So you can see that it's going through all of them, and it's allowed me to enter 4 lots of dice, okay? And I mean, I hope that it's stored them, but I haven't printed anything out, so I don't know what it's stored where yet. So basically, the while loop has allowed me to pulse through and enter it for the number of players. So what has happened is in my array, I have the 4 different elements. Each one is a struct, and it allowed me to go from struct at index 0 to struct at index 4 to enter the numbers for each different player. But it allowed me to do 2 integers for each one of those. Okay, so lovely. Now we've scanned in all the numbers. I would like to print it out so I can see if I've made a mistake somewhere or not. Okay, so I think maybe I'm going to do it as a function just to give you a little bit of a, why not? Just to give you a little bit of a fun movement on functions as well. Yeah, so Lisa's asked, should the printf have I+1? It really can, because it makes it a lot nicer. Because then it's player 1, player 2, player 3, player 4, as opposed to player 0, which we don't usually count like that in real life. So yeah, that would be something that would map a lot better to how we do things in real life if we have I+1 there. All it means is just going to look a lot nicer. So it's going to ask us for player 1, player 2, player 3, player 4, as opposed to player 0, player 1, player 2, player 3. Okay. So I'm going to print the scores, and I'm just going to, I might call the functions print scores. And what do you think I would need to send for this function if I'm going to print the scores? I really need to give it the array, don't I? Because if I give it the array, then I'll move the array into the function, and I can pulse through the array, go through all the different separate indexes, and print out what's going on. Now, in order to send an array to a function, all you need to do is just give the name of the array. That's all you need to do, okay? And we have done that by saying print scores, and then we're going to say roll. Okay, so I'm going to do it as a function now. Okay, and the function is called print scores. Now, if you remember, when I do my functions, I have what the output is. Then I have name of function. And then in brackets, I have the input to the function. Now, what do we think will be the output? Are we outputting anything? Are we returning anything at all to the function? Well, not in this case, because we're just going to print stuff out. So we're not returning any numbers. We're not returning any characters. We're not returning anything at all back. So it's going to be a void because there's nothing that we can return at all. And then what we're giving it is we're giving it this array of structs, okay? So I have to tell it that I'm giving you an array of structs. So I'm going to say the data type is here, my array is called roll, and I have to tell you that it is an array. So I've given you an array of structs. Yeah, void. Well done. Just printing. Well done, guys. Well done. Good pickups. Okay, and again, if I'm printing, it's going to have a loop. I'm going to have like amazing things going on with my loop. So I have my lovely loop control here, int I is equal to 0. You guys are going to be now not just nightmares of semicolons, but nightmares of I's. Next week, it's going to be I's and J's. So a lot to look forward to. Okay, so then we're going to have a while. We're going to have some sort of condition in here. And of course, we're going to update our loop control. Okay, so my condition, if you've noticed, every time I do the array, you're probably getting quite used to this condition now, is to go through the whole index, I has to be less than however many things there are in this array. And we've got a hash defined, so it's I is less than number of players. So whilst I is less than the number of players, I'm going to print out what's going on. So I'm going to print out what's going on, and then I'm going to increase it. So let's have player D rolled a 1 number and the second number, so the 2 dice, yeah? And what I'll do then is I'll put a new line in. And so then what's going to happen, comma, okay, let's fill in all our, so we've got 3 different format specifiers here, which means I need 3 variables to make the place for it. So the first one is I. Well, we've said it looks pretty ugly when it's saying player 0 because there's no really such thing as player 0. So instead of I'm going to be a bit tricky and say I plus 1 because that will allow me to say, you know, player 1, player 2, player 3, player 4. So there is no actual functionality to it. It's more that it looks a lot neater if you do that. Okay, and then I need to access my array. So I'm going to call the name of the array. And in the square brackets, I'm going to use the index for the element that I want. And the first number is my die 1. So I'm going to use this dot to access the member. So die 1. And then I'm going to do the same thing for my second one. So roll I. And now instead of that, I'm going to have die 2 because I'm accessing what the second die is. Close the bracket, semicolon. Don't forget the semicolon. And that will form out our print function now. So now we should be able to not just scan in, but we should be able to print stuff out. So now let's run it. I'll clear this, and now I'll compile it again. And what's happened here? It's given me a lovely error here. Warning, implicit declaration of function is invalid. Now, if you guys remember what that means, it means that I've called this function over here. C has no idea this function exists because I haven't told it that there is something coming that has this name. So I've forgotten to do a function prototype before my main to let C know it's coming. So what I want to do is I want to place it above my main. And don't forget the semicolon yet again. We can't forget the semicolon. Semicolon is life. Save it. and let's try this again. Okay, I'm going to clear this out. I'm going to try and recompile it again, and then I'll try and run it again. Yes, people have noticed. Okay, and so now as you can see also, instead of saying player 0 like before, it's saying player 1. Okay, and then it's printing them out. Player 1 rolled a 1 and a 2, is that right? Yep, 1 and a 2. Player 2 rolled a 3 and a 4, yes. Player 3 rolled a 3 and a 2, so 3 and a 2 here, yes. And the last one rolled a 3 and a 4, and that is in fact exactly what they rolled. So now we have this wonderful functionality. Well, wonderful, I'm not sure it's wonderful, but it's functionality to print something out, to scan something in. So just going through the array and kind of, you know, heading out and doing different things with it. So someone's asked a question, can you declare I twice if one is in a function? So remember, when I put I in here, what happens is this int I that I've declared in here only lives between these curly brackets. It dies as soon as this is over, okay? So this int I is equal to 0 here is different to this int I is equal to 0 here. They're two different things. So you can declare them in different functions. They're not the same. Okay, let's continue solving things. Okay, so we've done pretty well. We've printed stuff out. We've scanned stuff in. We've grouped stuff. Okay, we need to sum the dice now. Okay, how would we sum the dice? So could be a really nice place to have another array. Why not? Live a little, have a second array going, and you know, and then just, you know, live life to the fullest. So let's do another array, an array of ints, and in that array of ints, we're just going to store the sum of all of our different the different additions. So, okay, someone's asked whether you can declare them in different functions. Is it a good style to still name them separately or not? Okay, so basically, the I is a kind of a specific name because it stands for index, and there is also, you'll see, there's a J as well, which we'll learn about next week, and those ones are really okay to kind of use throughout, but also they're okay to use as single letter variable names as well. So it iterates through, and J will iterate through something else, and I'll show you what it does next week, okay? So I is either index or iterating, okay? And it's a common one to use. So when people read through your code, you will know what I means. People usually use it as a way to count through something. Ah, Alvin, that's it. I didn't realize it could be from vectors in maths. It could well be. That's a great point. Okay, so let's add them up, and you know, why not? For fun, let's do another array that will store our sums in them. Okay, let's do. Oh, Lisa, even better way to do it. Could we change the struct and have the third element be the sum of the first two? We could do that for sure. That's also a nice way to do it. Very nice way to do it. I'm now trying to think which way to do it. Okay, I'm going to do. Which way should we do it? I'm just going to do another array, but you definitely can have another element in the struct, another member in the struct rather, that you can have as the sum, and maybe you can, you know, do that outside of the lecture as well and practice around with it, because that's a really fun way to solve it as well. So I'm going to have an array of ints, and I'm going to have, that's my sum of the dice, and again I'm going to make it an array, and it's going to have for all the players, so for each player it's going to have you know, a lovely way to do it. I'm going to initialize it to a bit of nothing to start with, and then I'm going to loop through my array, loop through this array here, and I'm going to place the sum into each of the different indexes, okay? So let's have a look what we have in here then. So if we're going to loop through, again, I'm going to, I think I've used I already, so I would come out of here, I would be something else. So I'm going to bring it back down to 0, not an O. Again, I keep trying to make I an O. Okay, then I'm going to create a lovely loop in here. And again, I'm going to go from 0 until the number of players. So until the end of my array. And what I want to do, and I'm going to update, don't forget to update always. And what I want to do is I want to store into my sum dice the sum of each of the different elements. So the sum dice at index I, yeah, is going to be equal to, and I'm going to add them up now. So my whatever is stored inside roll I die 1 plus whatever stored inside roll I die 2. Yep. So roll at index I, accessing the first dice by saying dot die 1 plus the array accessing at index I, whatever is dice 2, whatever stored at dice 2. So what that will do is that will load up my beautiful sum dice in here, and it will be it'll be able to give me a lovely way to do things, a lovely way to keep track of things. But there's obviously many different solutions as well. Okay, so now I've got all my different sums. I really want to figure out who's the winner now. Yeah, so when we finish rolling 110 each, find out who wins with the highest score. Yes, okay. Now we know the different sums. Let's figure out who is going to win for us. And I'm going to move this function call outside to here. Okay, so let's have a look. So we want to be able to find the current winner. So what we want to be able to do really is we want to loop through this sum dice array and find the highest score. Okay, again, we have to do a loop, okay? So working with arrays is working with a lot of loops, okay? They love loops because the way to go through an array or traverse it is to go through a loop. So let's do that now. And we can see what we might need to keep track of. Okay, I'm going to go in here whilst my condition, so nice, always I number of players, or I however many elements there are inside my array. And I'm going to update the loop control. Okay, so now what do I need to do in here? I need to figure out if one is bigger than the other. And is the next one bigger than the next one? So this is quite an interesting, yeah, Michael, it is a lot. I know it is a lot, but we will go over arrays again next week as well. So it's a very solid introduction to arrays. But look, if you have a look at what we're doing, in fact, I'm writing basically the same piece of code each time. So each time I'm looping through and I'm either scanning in or I'm looping through and I'm printing out. So I'm playing with that array in exactly the same way each time with a while loop. So notice that there is a lot of similarity in how I'm solving it. But yes, there is a lot of code. And we might stop after this part here because there is a lot happening. And again, don't worry, it's your first taste of arrays. We are going to use them more and you are going to get some practice with them as well. So sorry, a bit excessive on the problem solving here. No, I realize that there's a lot in here don't worry, it will all become, we will reinforce each of these during the lectures. Okay, so in fact, maybe have we gone too much? Have we, I don't know if we should do the next part of this problem. Yeah, let's just do it. Okay, so we want to loop through this array and find where the biggest number is. Okay, so how am I going to do it when I know where the biggest number is? And this is a very common problem in computing where we have to try and find the biggest number, how we compare things. Does anyone know how we do comparisons in computing? We might just talk about how we do it, and then we're going to leave it. I think you've had enough of arrays for just today. But does anyone know how we do comparisons in computing? There are some functions, obviously, but without using a function, how would you do a comparison? And it's a really common way to do it. So it's kind of like, becomes like a bit of a design pattern as well. And the design pattern really is, well, not a design pattern, it becomes like a programming pattern. Okay, let's say we have 4 numbers. Okay, we're definitely going to use an if statement. Well done. Yep, so Zach, we are going to check if one variable is bigger than another. So we need to have, let's say we have 1, 2, 3, and this is terrible. It's not writing very well, sorry. 2, 3, and 4. Okay, so what I'm going to do is I'm going to check, is 1 bigger than 2? And if it is, I'm going to set the bigger number. So is 1 bigger than 2? No, it's not. So I'm not going to set anything there. Is 1 bigger than 3? I'm asking the wrong questions. Hang on. Sorry. Okay. Here we go. Just a quick run through this. Oh, maybe I'll write in crayon. Okay, let's say I have 1, 2, 3, and 4. Okay, my first comparison is going to be, I'm going to compare 1 to 2. Which one is greater? Is 1 greater than 2? If it is greater, which it's not right now, I'm going to say, okay, 1 is greater. So I'm going to say that the biggest number is equal to 1. Then I'm going to compare it to, which doesn't make sense because it's actually 2. 1 is not greater than 2. It should be the greatest number is 2, and now I've done that one. Then I'll go to the next one. Is 2 greater than 3? No, it's not. So 3 is the greater number. So now I'm going to say 3 is the biggest number. So then I'm going to compare 3 to 4 and ask, is 3 greater than 4? No, it's not. So 4 is the greater number. So you kind of have to keep track of what is the greatest number, and you compare each time as you cycle through the array. Yeah, so you compare it until it's not the biggest, and then you set what is the biggest. And then you keep the comparisons going each time. And we're going to revisit this next week. Don't worry if it hasn't made a lot of sense to finish on. But basically you keep comparing, and that drawing is terrible. I'm sorry, I don't know. There's a huge lag in my drawing. And so it's causing it to draw really weird shapes. All right, we're going to finish there for today. That was a huge introduction to arrays. I hope that you're all still standing or sitting. You might need a bit of a break after this. And don't worry, what we will do next week is we will actually go through and do a little bit of a revision as well. So we're going to actually just, revise all of this stuff and go back over it a little bit more so that you get a little bit of a rehash of what's going on. So don't worry, it's your first taste of arrays. Just when you go and have a look at this code after this lecture, I want you to just have a look and realize that the while loop is kind of always very similar in the way that we move through the array. So whatever we're doing, we always have that loop where we, go through the array and try and move things in. If you have any lecture feedback, please let me know. Otherwise, have a wonderful rest of the week. Good luck for the first weekly tests. Remember, you might not be able to do them in an hour, and that's okay. And other than that, we will see you next week, which is going to be a big week. So get ready to, party, I guess, with the assignment and everything else under the sun. But, at week 4, flexibility week is coming. So have a good rest of the week, guys. See you later.